Uh, Quick video. Guess what? I started a new project. Bet you didn't see that one coming. Um, so this project is extremely early, but what I've wanted to do for a while is simulate gas and see if that has any interesting applications for making a game set in space where you could have pressurized compartments and damage to those compartments could result in gas escaping. So I've got an extremely crude simulation of some gas here. So I've got a bunch of non-kinematic boxes around the edge and a bunch of little spheres bouncing around inside. So they're set to have perfectly elastic collisions and they have no friction, so they don't rotate. So they're just pinging around in there, roughly Brownian motion. They're zooming around, and so if there were a box in the middle of here and these balls were sufficiently small, that box wouldn't move because it's being bounced against on all sides evenly and wouldn't move around because all of the bounces even out. Now in reality with balls this size it would sort of jitter left and right and up and down slightly because the simulation is very crude and the balls are very big, so on average over a period of time all the forces would even out, but on a moment-to-moment scale you would sort of see it vibrate a little bit. But what I've set up is I can hit a button and one of the border boxes will become kinematic, so physics can act upon it. And if it were a section of a bulkhead in space, and so there's no gas out here, so this is a vacuum, the forces of the atoms of gas inside bouncing against it would result in it being forced out, and then the gas could then escape through that hole. So let's do that. Button press. Oh, look at that. So it took a little while for a particle of gas to bounce against it, and that forced it out. And you can see the gas is slowly escaping through that little hole there. It's very cool. So it's pretty computationally expensive to do this. I'm using the ODE, I don't remember what it's called, Open Dynamics Engine. Yeah, that's it, ODE. So it's currently using, where are we? Well, it's not using that much, only using 2% of a processor, but that's still a fair bit. So if I were to be simulating much smaller balls, it would require a lot more processing oomph. So I could probably, just quickly, increase the number of balls and decrease their size. So let's double the number of balls, and decrease their size by a factor of 2. This may go horribly wrong, but let's see what's going to happen. Whoa, Jesus! Okay. So I should also scale down the force to which they are subjected, because the size determines. So a lot is still escaping, but so they're escaping because they're traveling so fast that when you get to the edge, by the time it checks to see if the ball has collided with the edge, it's already on the other side of it and it just flies off into the void. So let me just reduce the force again. There we go. Okay, so fewer are escaping now. There's a lot of interesting analogues here between real physical systems in the simulation. So if I release this block, it's doing that again. So for some reason I haven't been able to work out entirely. When I enable physics on one of the edge boxes again, things start to go crazy. All the balls just start flying out through the walls. Don't know why. But anyway, that's pretty interesting. My idea is to make a web game that runs in a browser, but all of the complicated physics is done on the server side The client would do some rudimentary like appearance physics to make things look as though they're moving smoothly, but the server would be doing all the number crunching. That's the plan. Okay, bye bye.